Thank you for your introduction. So I'm going to present our project about how we can leverage crowdsourcing to create interactive prototypes at early stage of UI design. This is a collaborative work with my colleague, Yujin, Isabelle, Yiwei, Stephanie, and we are all from Chroma Lab, which is directed by Lasecki. Creating sketchy prototype is an essential step in user interface design, and it helps designers quickly explore different ideas and use it to communicate with their colleagues, because it is easy to get a sense on how the UI will look like. However, it is not clear from a sketch to know what's going to happen when a user interacts with it, because it is not interactive, rather static. Indeed, a previous study reported that designers express difficulties in prototyping UI behaviors. Typically, what designers do is to describe the behaviors in text and annotate on the sketch. However, if you think of the actual behaviors on the final products, like you see on the bottom, it would have been difficult to get the same feel from the textual description. For example, when Steve Jobs demonstrated swipe to unlock 10 years ago, people were applauding and screaming. However, you would not have the same excitement if it reads swipe to unlock from the sketch. Our goal is to develop a tool for prototyping interactive behaviors that is agile for rapid iteration, easy to use for non-experts, and expressive enough to support general UI application. We have a solution for the appearance of a sketch, which is pencil and paper, which provides expressive and natural ways to create a rough sketch for UI. So our question is, what is something equivalent to pencil and paper for prototyping interactive behaviors? There are potential solutions to address these challenges. For example, most of UI design software these days provides a library of animation that you can choose from. However, oftentimes the library is focused on certain types of apps, such as mobile app or website transitions. And it requires a high fidelity prototype, which makes it difficult to explore ideas at early stage. Another potential solution to this problem is to use tools that are developed in context of creating animation. K-Sketch, for example, provides an easy-to-use environment where end user can create animation by demonstrating behaviors and later editing it on a timeline editor like film editing software. We draw lots of ideas from K-Sketch, in fact. However, apps like K-Sketch produces one linear animation, and it does not scale well for one UI that contains multiple interactive behaviors. Lastly, the tools developed for interactive illustration can be useful to quickly explore ideas. It provides rich expressivity and interactivity, but this is still kind of an end-user programming, which requires computational thinking. So all of these approaches are valid in its context, and however, each approach has some limitation that makes it difficult to use for UI prototyping at the early stage. One of the effective methods is to create a paper prototype and then manually demonstrate the behaviors. As you can see, but it could be very labor-intensive and time-consuming to create the prototype and perform the demonstration. Another problem is demonstration is ephemeral, so you would have to videotape the demonstration to archive it. And the artifact, which is paper prototype, does not know anything about the behavior. Lastly, there are certain things that cannot be done manually because simply human cannot do it because of the limits of our physical motions or the materiality of the paper prototype. As an alternative, Apparition addressed the problems of manual demonstration by collective crowd workers collaborating on a real-time shared canvas. In the user study, the requester asked workers to demonstrate simple behaviors, as you can see in the video, like moving the character to where the requester clicks. Still, the system shares the similar shortcomings of manual demonstration. To address these problems, we introduced SketchExpress, a web-based sketching system that helps designers prototype complex interactive behaviors. It takes the idea of crowdsourcing from the previous work of Apparition, and it is in fact built on top of Apparition. So in SketchExpress, a requester or designer verbally describe the interactive behaviors they want, and the crowd workers that are connected to the system listen to the verbal description and create interactive behaviors in real time. We provide an easy and expressive method called demonstrate and remix to make the static sketch dynamic. The method allows non-expert crowd workers to create animation in a few minutes. At the end of the day, the designer will have a sketch that includes multiple interactive behaviors that can be triggered individually or simultaneously by anyone. Our eventual goal is to have an intelligent system so that designers can hand off their work of refining UI to crowd workers. As a requester's interaction with the system is natural, non-expert designer will be able to use the system with minimal training. In this paper, we focused on the method that we provide to the crowd workers. I will explain the technical details of the demonstrate and remix method from now on. In SketchExpress, one can create an interactive behavior by demonstrating it. So this is the interface that crowd workers use. A requester will see the same thing in real time on the canvas. Once the requester will speak to the system and verbally describe a desired behavior, let's say a requester wants a crowd worker to create a behavior of Super Mario moving forward and jumping forward. And then crowd worker listen to the verbal description and start recording, name the animation, and demonstrate what is supposed to happen in the canvas for that particular behavior. Once created, one can replay the animation, and any changes made in the canvas during the recording phase will be reproduced as a behavior in real time as it was demonstrated. You can see that on the right side, as a worker demonstrates, the system knows what kind of operation that the worker makes on which element for how long. Once the recording is complete, one can reset the animation so that it can quickly restore the initial state of the animated elements so that the behavior can be demonstrated again. Because requesters' interaction with the system is natural, they can freely, is fluid. And suppose a requester asks the crowd worker to come up with a different kind of jump behavior, and then crowd worker can be created to satisfy the subtle request. Okay. So what happens if I replay the behavior one more time? SketchExpress does not replicate the demonstration as a series of snapshots of the element. Instead, it's going to repeat the behavior based on the current state of the element. This is because recording algorithm computes the difference between each event during the recording phase. And it will replay based on the calculated difference, which we'll call delta here. And this will work for any affine transformation, such as translate, rotate, and scale. So recording and replay by delta will expand the expressivity of animation in SketchExpress. Here's an example. Let's say I recorded an hour hand of clock moving from 1 o'clock to 3 o'clock, which is basically rotation by 60 degrees. If the behavior is replayed again, the hour hand will move from 3 to 5, 5 to 7, and so forth. Now the behavior is not moving from 1 to 3. Instead, it is 2 hours of elapsed time. Another benefit of replaying by delta happens when a user triggers multiple behaviors simultaneously. This allows complex interactive behaviors that need concurrent action. For example, if I want to express a rolling stone, there's no way a crowd worker to manually demonstrate the behavior because rotation and translation of an element occurs in two exclusive modes. However, separately recorded animation of rotation and translation can be replayed together to express the rolling stone animation. Most importantly, SketchExpress allows crowd workers to remix the demonstrated behaviors afterwards. Suppose the crowd worker is asked to create a behavior of mushroom dyeing, like in the top right picture. First, the worker will simply record the behavior based on what is supposed to happen. However, the demonstrated behavior is far from the example on the top right. It is because the recorded behavior happens in real time as it was demonstrated. For example, it takes too much time to rotate the mushroom and it does not immediately transit to the next motion. In this case, a crowd worker can use remix function to adjust the timing of the behavior. In the remix function, a crowd worker can choose to change the duration of each operation individually, to replay an animation instantly, or even skip the operation if not necessary. For example, in this case, the rotation operation should happen instantly, and we don't want any delay between any two operations. And the worker can adjust the time of the move operation as well to make it more dynamic. As the behavior is getting remixed, you can see that worker accomplishes the seamless behavior, which is close to the example on the top right. Lastly, the created behaviors is an object in SketchExpress so that you can reuse it for other visual elements in the sketch. For example, let's say the turtle has its own behavior of hiding in a shell when Mario jumps on it. However, if the turtle moves in the same way that the mushroom moves, or die in the same way as the mushroom dies, we can reuse the behaviors. A crowd worker can simply create a duplicate of interactive behaviors and apply it to another element. This is the reusing the behavior in action. Suppose the behavior of mushroom dying can be applied to the turtle. A crowd worker can clone the behavior and rename it, and then one can apply the behavior to a different element in the remix function, in this case, the turtle. The crowd worker simply needs to click the element and apply the behavior to it. There are a set of functions in the temporal dimension that we didn't explain in detail for the sake of time, such as looping, concatenating, inserting. Please refer to the paper for more detail. So this is an example of how far we can go with SketchExpress. This is done by one of our undergrad students demonstrating the game Flappy Bird. As you can see, the game character, the background, and the game over screen itself, it's animated independently. Imagine how long it will take to demonstrate these kind of behavior by programming, or how many people you will need to demonstrate this with paper cutouts. You may be focusing on the left side, but the more interesting things are happening on the right side. By pulling the levers of right animate, right time, one person can accomplish to demonstrate how the game works effectively. Automating the process of manual demonstration is another benefit of using SketchExpress, and all of these could be done in tens of minutes, so by one person. Another thing to note that is, this is non-linear, so based on the order and the timing of triggering behaviors, you can demonstrate a completely different scenario, like where Flappy Bird reaching the ceiling, or it dies because it goes out of the screen. To validate the effects of SketchExpress, we conducted a user study with 18 crowd workers recruited from MTurk. We had 3 different conditions. The first condition, or C1, is baseline condition of Apparition, where crowd workers need to manually demonstrate a described behavior. The second condition, or C2, is the one that has function of demonstrate and replay, but not remix function. We added C2 condition to identify the effect of remix function. The third condition, or C3, is the SketchExpress condition. One of the authors acted as a requester by reading pre-written script of describing the behavior. We had 5 different UI scenarios, from games to traditional GUI like to-do list. We had total 9 different behaviors that we asked to demonstrate or create. We told workers to demonstrate the behaviors twice and allow them to replay the created animation in condition 2 and condition 3, which had replay functions. We analyzed the screen recording and evaluated with a set of binary rubrics per demonstrated behavior. For more detail on the analysis, please refer to the paper. So we confirmed that the effect of both replay function and remix function. The figure represents a precision and recall of these, the 3 conditions, C1 baseline, C2, the one without remix, C3, the SketchExpress. Increase in both precision and recall compared to the baseline condition was statistically significant. In terms of precision, being able to skip operation helped accomplish 99.2% in precision, because workers can simply skip any extra operation made during the recording. Also, we could confirm the effect of remix function, yielding the increase of 27.3% in recall. The remix function significantly improved the quality of the demonstrated behavior. Again, we asked crowd workers to demonstrate the behavior 2 times. This figure shows the completion time of the first trial and the second trial for 3 conditions. Apparently, creating behaviors in SketchExpress comes at the price of needing more time to refine the behaviors. Still, workers were able to create one interactive behavior in 174.5 seconds on average, which is less than 3 minutes. The real benefit comes from the repeated use of behaviors. For the second trial in condition 2 and 3, Workers just need to press the right replay button. So once an interactive behavior is created, now it is the matter of human computation to find out which button to press. Crowd workers really enjoyed the task, sometimes more than we hoped. One observation was that they spent too much time in remixing and retrying the animation, while it was already good enough based on our rubrics. For example, one worker spent more than 13 minutes to make the behavior look perfect. In practice, a requester will give immediate feedback to stop them refining. Lastly, we didn't do any formal survey with crowd workers, but they voluntarily sent us positive feedback after the sessions. In summary, the lab study reports that the crowd workers can prototype an interactive behavior within 3 minutes, on average, with a 27.3% gain in recall compared to the baseline condition. Our contribution will be the method of demonstrate and remix and replay method, which can be used in any kind of relevant software, and the system that allows crowd workers to create interactive behaviors. One takeaway of the study is that we can mitigate the challenge of real-time collaboration, ironically by bringing some asynchronous interaction technique, such as recording, replaying, or remixing, which release the real-time pressure. Our bigger goal is to create an intelligent assistant for GUI sketching tool. Apparition and SketchExpress let us explore the basic functionality powered by crowdsourcing, and we are excited to take this further. Immediately, we would like to understand the challenges that the requester would have to verbally communicate and to collaborate with crowd workers in real time through qualitative user study. In addition, we would like to take advantage of the crowd creation and demonstration to automate the process of creating a GUI sketch and computationally generate the sketch based on the requester's description and minimal visual input. Thank you for your attention. Last but not least, I'm on the job market this year, so if you need a technical ACI person, a researcher, or a teacher, or all of the above, just let me know. I'll be happy to take any question.
Steve Feiner, Columbia University. This is really neat stuff, and you're positioning it for prototyping and early sketching, right? But in this kind of like 8-bit graphics look, which a lot of people really like, even for finished products, it looks like it could be an interesting way to make games that are continually maturing and evolving, maybe courtesy of having crowd interaction, so the game actually changes in interesting ways from one day to another. And it's not just, you know, an early prototype, but it's actually the real thing that people are playing. Have you thought about that?
I completely agree with your thought. Actually, the stuff that you see here, you see like 3 arrows button on the down on the bottom. I actually just fiddled with a crowd worker, and then I was clicking one of the buttons, and then I asked the crowd workers to replay the behavior based on what I clicked, and then we were kind of playing game, and there was like you know, eagles trying to catch chicken, and then wandering around, and then I asked the crowd worker to come up with something creative that he or she wants to have, and then I thought this person will come up with something about game, but like this person created this like animation that sunrise from the horizon. So it was very rewarding, but like I like the fact that it like the crowd workers' take was something that I have never thought of, and then it actually will facilitate creativity in some sense for the end users. Does that answer your question?
Thank you.
Thanks.
And thank you very much. We unfortunately